Hello, today we are going to be estimating a two-step generalized method of moments using the IVREG2 command. We'll be estimating a two-step generalized method of moments using the IVREG2 command. And one of the key reasons why we use the two-step GMM estimator is because it easily accounts for the problem of endogeneity. It easily accounts for the problem of endogeneity. So today I want to estimate the model in STATA, and the command is IVREG2 command. I want to estimate the impact of GDP, renewable energy, and urbanization on CO2 emissions in Africa. So my dependent variable is the log of CO2 emissions, and I am making an assumption that renewable energy is exogenous, and I'm also assuming that GDP and urbanization are endogenous. So my endogenous variables will be inside the brackets along with their instruments. So log of GDP urbanization is equals to, and I want to use three lags to instrument for GDP and 2 lags to instrument for urbanization. So we have the log of GDP, the first lag LGDP, L2.LGDP, L3.LGDP, and I'm using 2 lags for urbanization, L2.URB. And I must not forget, I have to also include in a GMM model, in most instances, the lag of the dependent variable must also be part of the explanatory variables. So I am including the lag of the dependent variable in my model. So I place a comma and GMM2S to tell STATA that you are estimating a GMM model, and I click enter. Now this is the result of the two-step generalized method of moments. As you can see, it is quite easy to estimate, and you can see that GDP has a positive effect on CO2 emissions, urbanization has a positive and insignificant effect, renewable energy reduces CO2 emissions. We can also see that the model is not under-identified when we use the Anderson-Cannon LM statistics, and we can also see that the Sagan test says that the model is not over-identified, which makes our GMM model a good model. However, we could see here that statistics are consistent for homoscedasticity only, so we could try to account for heteroscedasticity in our model and even autocorrelation, and the command for this is the BW command. Let's use BW2 and robust. We click enter. So we can now see that statistics are robust to heteroscedasticity and autocorrelation, and we can also see that GDP still has a positive and significant effect on the log of CO2 emissions. Urbanization has a positive but not significant, and renewable energy has a negative effect. We could see that the model is still valid. The under-identification test of the Kleberg-Papp-RK-LM statistics, which it now produces under the robust estimator, shows that the model is not under-identified, and we can also see that the Hansen-J statistics, the model is not over-identified. So we could also test for autocorrelation in our model using the ABBA command, ABBA lags 2. So we could see that our model does not suffer from serial correlation using the AL2 test, the Ariano bond test for autocorrelation. Our model does not have the problem of autocorrelation. Thank you very much.